Hello, and welcome to my maths video. This week, we're talking about area and what it actually is. So let's start with an example. Looking at these two L shapes, we can see that the one on the left is bigger, but how much bigger? And how can we show this? One idea would be to fill our L's up with lots of copies of a smaller shape. The L on the left takes 16 squares to fill, and the L on the right takes only 4, so the L on the left is bigger. What about shapes other than squares? The L on the left is 32 triangles big, but the L on the right is only 8 triangles big. Whatever little shapes we use, for the L on the left we need 4 times as many as for the L on the right. We can say that the shape on the left is 4 times as big as the shape on the right because of this. And incidentally, there are plenty more little shapes we could use. The rule is, if you've seen it as bathroom tiles, you can use it to calculate area, but squares are traditional, so let's stick with them. And final point for the definition, talking about little squares is perfectly valid but sounds a little unscientific. If each side of our little square is a centimetre long, then this is called a square centimetre, and the symbol is centimetres with a little squared above it. If each side of our little square is an inch long, then this is called a square inch. If each side of our square is a decimetre long, then this is called a square decimetre. And it's important to realise that a square decimetre, a square metre, a square centimetre, and so are actually all real things. You can cut them out of cardboard and use them to measure how big something is. Now that we're done with the definition, let's have a look at some examples and some calculating tricks. We'll start with a rectangle. Here, the rule is that the area of a rectangle is its height times its width. A very natural question is why, but let's just do the calculation here first, and get to the why in a second. Since our rectangle is 5 centimetres tall and 6 centimetres wide, 5 times 6 is 30. So our rectangle has an area of 30 square centimetres. And why could we do this? Well, if we make a stack of little square centimetres as tall as our rectangle, we need exactly 5. And to cover the whole rectangle, we need 6 of these stacks. Thinking about multiplication, 6 stacks, each with 5 squares, is 6 times 5, which is 30 squares. This naturally works for any rectangle, so here's a quick exercise. What's the area of this rectangle? Feel free to pause the video and try it yourself. And now the solution. Our rectangle has a height of 3 and a length of 7. 3 times 7 is 21 square centimetres. And if you want to try it again, here's 2 more exercises. So, that's it for rectangles. Notice how one of the last examples was actually a square, but the area could be calculated in exactly the same way. Our next shape is a triangle. Here the rule is that the area is half the height times the width. Again, a good question is why, but again, let's do the calculation first. So the height times the width is 5 times 4, which is 20, and half of that is 10 square centimetres. And now for the why. Well, if we think about it for a while, we might realise that 2 of our triangles make a rectangle. The area of this rectangle is 5 times 4, so the area of our triangle must be half of that. This naturally works for a bunch of other triangles, so here's a quick exercise. What's the area of this triangle? And now the solution. And if you want to try it again, here's 2 more exercises. And what about other triangles that perhaps aren't so neat, like this one? Well, funnily enough, the rule is exactly the same, and the area is half the height times the width. The width is the same as before, but the height is perhaps a little harder to find, as it's not one of the sides of our shape. Let's calculate the area. The height times the width is 4 times 4, which is 16, and half of that is 8 square centimetres. And now for the y. To make the rectangle, we first have to make a copy of the triangle. We split this in half, separate the left and the right, and then stick them on top of the original triangle. And now a quick exercise. What's the area of this triangle? And now the solution. And if you want to try it again, here's a couple more exercises. So what about more complicated shapes? Well, one of the things that makes areas so great to calculate is that we can cut them up into smaller pieces without changing the overall area. If we make a cut here, then we get a rectangle and a triangle, and we can calculate their areas like normal. The height is 2 centimeters, and the width is 7 centimeters, so the area is 7 square centimeters. The height is 3 centimeters, and the width is 7 centimeters, so the area is 21 square centimeters. If we add both of these two together, we get 28 square centimeters, which is the area of the original shape. And if you want to try it yourself, here's another exercise. And now the solution. Well, the video's over. I hope you enjoyed it. Today though, as is often the case, there's something small I swept under the rug. It won't change anything we looked at, so feel free to stop watching, because it's just one very specific case. Namely, why is the area of a triangle like this also half the height times the width? It is in fact so. We can do the calculation. The area of this triangle is half of 4 times 5, which is 10. But where's the rectangle we can halve to get this triangle? Well, we have to do 2 steps to get it. First off, we copy our triangle so that we have this 4-sided shape. This shape now has 2 times the area of our triangle. It's made from 2 of them. Now we have to cut along this line and shift the right-hand bit around to give us our rectangle. And important is that when we cut our shape up and move the pieces around, we haven't changed the area. So this rectangle is still 2 of our original triangle, just cut up and rearranged. Again, the main takeaway should be that the area is half the width times the height. But for me at least, I find that it's interesting to see why this is the case, even with some strange looking triangles. And now that really is it from me. Thanks so much for watching, and until next time.